I'm going to review the Peak Electronic Design ESR70 Gold. This is the gold version, which is the newer one. I think it was released at the end of last year. I don't think there's any reviews out there yet. Let's check it out. So, Peak Electronics are known for making simple and yet very effective test equipment. I've got a few of their items already. So this is their standard form factor. Now I actually already have the DSA50, DSA75 and the Zen 50. This is given to me for free by Peak Electronic Design for the purpose of review. So I haven't paid for this. This has been given to me at no cost. So just a general disclaimer. But I will still try and ensure that my opinion is true. I don't want to have a skewed opinion just because someone's been given to me for free. So there's the actual tester. Here is the physical manual. Now the electronic manual is also online, so down below there'll be a link going to Peak's website. On the page for this you'll see that there's a manual download, stuff like that, so you can actually download the manual for this thing and look at it yourself. Alright, so if you want to read the manual, see it yourself. So ESR and capacitance meter. And here's the gold version of high speed capacitance measurement. This is the difference between the original ESR70 and the gold version, is that the gold, the new one, which is I think actually replaced the original version, is actually faster for doing big capacitors. They've increased the current from 2 milliamps to 20 milliamps on big capacitors, so it will be a much faster test. So you've got the usual manual stuff here. We'll look at the specs in a second, it'll be towards the back, and how to use it, a bit of information about capacitors, so you actually know what you're actually doing, how to analyse them, how to interpret the results. There's a capacitance chart, generic one. So this is based on Panasonic FR series capacitors. Also has some extrapolation from non-mentioned values. This chart is actually quite interesting because another chart which I got from I think it's from their previous ESR version, and that one actually had different values in here and they were lower. So this one's a bit more generous than the original. I'm not quite sure why. To me some of these values are actually quite generous, but it's based on this apparently. There's a ESR curve plot, so this will allow you to actually understand what's going on with the different capacitance values and the internal resistance. Just gives you a bit of an idea what's going on. It's got a buzzer on it, well, a little sounder, which you can actually turn off if you choose not to like it. I think it's a good thing, but if you want to turn it off you can, it's an option. You can also do probe conversation. This comes with plug-in 2mm probes. They plug in. This is obviously clips, but you can get little probes that go on here as well. They sell those. Kit usage and stuff, and troubleshooting, diagnostics, and specs. Let's get a close look at the specs. There are the specifications. Read those in your own time. Warranty information. Peak Electronic Design do really good product support. If you blow this thing up because you make a mistake, you can send it back to them and they'll fix it for you. At a cost, obviously. If you make a mistake and you destroy it because you've done something silly, you can still get it fixed. You have to pay for it, that's all. So I think that's really good product support. I haven't had to do that yet. I've been lucky. I haven't done anything silly. Don't forget to click like if you like the video, and subscribe and click the bell icon too. If you want to see more videos, I'll be doing reviews on electronic test equipment or anything else I may be doing. Repairs or whatever. Anyway, that's enough waffling. Let's have a close look at this thing. So like I said, it's got these connectors on here. 2mm plugs. If you .2mm plugs, so you can actually swap these out for probes or other accessories just by plugging them in, as long as you've got a 2mm socket on them. So Peak do sell alternative leads for these and all sorts of other accessories, so check out the website for those things if you want different setups. But this is what's supplied with it, is these crocodile clip leads, which appear to be gold plated. So this meter will do in-circuit and out-of-circuit capacitance testing. It will tell you capacitance value if it can. There's circumstances where it can't measure value, like if it's in circuit, maybe there's some other circuitry around which will interfere with the reading. In that case, it will just give you an ESR instead. It won't show you the capacitance. I've got a circuit board here to look at. This is a working circuit board, there's nothing wrong with this. So we can actually do some in-circuit testing. I'll show you some other ones as well. Turn it on, you just push the on button. There you go. Firmware version 6. Now it's monitoring for components. So it will sit here for, I think it's got like a 1 minute auto power off. You don't need to wait for that, you can always just push the off button and it will turn it off. It's also got the option here, type of test, there you go. So you hold that down there's a sound option, alright, so you can turn it on and off. Now I do want the sound on. This is the probe compensation menu, so if you want to do compensation with your probes, if you're not quite reading 0, if you short them out, you should get 0. If you don't get that, you might do a compensation, or if you've changed these to something else, there we go, it's gone back out. Right, so just turn it off and just restart it, just to be in case there's anything going on. Right, so that's monitoring for component. So if I hook this onto the capacitor, like this one, in circuit obviously, automatically found it. In circuit leaky, yes, that's fine. 0.01 ohms. That circuit is working. Let's do a different one. One over here. Let's clip onto here. There you go, measure that one in circuit, fine. Nice, it's a bigger capacitor. The little asterisk on the side there means it noticed it's a large value and the site used a higher current to do the test. That's at 20 milliamps. So when you see the asterisk, it's done a 20 milliamp test. Probes I'd actually recommend you buy if you're going to get one of these. Buy the probes as well. There you go, same thing. So this is really handy for doing in-circuit testing. It's really quick, and you don't have to clip them on. You could just touch them on, like if I find our capacitor over here, you could just touch them on like that. There you go. So it's got different bells, like the single bell and double bell. They mean different things depending on the ESR that's returned. So if it's above or below a certain value, it would do different bells. It tells you that in the manual, so you've got an understanding of what's going on. It's as easy as that. It's a good little tool. Very simple tool. This is what they make. They make simple, dedicated tools. So that's it. They do one job and they do it well. That's why, see these things are used by a lot of the YouTubers. You'll see a lot of YouTubers will have a Peak Electronics tester because they're good. Now apparently this can do 1,500 tests on the batteries. It's got a AAA battery inside it, which you can replace yourself. You take the screws out, you take the battery out, and it's in there. We should actually have a look actually. So that's wire here as well, I should mention this. This actually feels like silicone wire. It's really flexible, really soft. I'm pretty sure it's silicone. Those are nice, should be heat resistant. These are PVC that's on the end here, but these are silicone. Nice crocodile clips, say gold plated. Very good. So according to the manual here, right the way back in the specs, it's supposed to be able to cover 0.3 microfarad to 90,000 microfarad. With an accuracy of 0.2 microfarad plus or minus 4%. Test currents are 2 milliamps and 20 milliamps obviously. Maximum range is 40 ohms, so if it goes above that it will say it's basically bad. Resolution less than 2 ohms is 0.01 to 0.02. Greater than 2 ohms is 0.1 to 0.2. Accuracy is plus or minus 2%, plus or minus 2 counts basically. And ESR test current is between plus or minus 0.8 to plus or minus 23 milliamps. And ESR test frequency is basically 48 to 104 kilohertz in that range. And it's got some voltages here to which it can withstand. Abuse voltage for capacitors less than 10 microfarad, 275 volts. And greater than 10 microfarad is 50 volts. Although the discharge voltage limit is 50 volts. So if a capacitor's got less than 50 volts in it, this will automatically discharge it, otherwise it won't. It will just give you a warning saying you need to discharge it yourself. But it means at least it's got protection. So here I've got a capacitor hooked up which is a 0.22 microfarad, which is below the 0.3 it says it can do. Let's see what it says. There you go, 0.26 and 11.4 ohms. Okay. So here's a bit of a challenging capacitor for this thing, okay? So this is a 15,000 microfarad 35 volt cap from Nichicon. My DER D5000 can't read this capacitor at 1 kHz. Now I can only read it at 100 Hz or 120 Hz, and I'm getting 13 millifarad or so, 13.4 millifarad. You can't get an ESR measurement on that. I'll do dissipation. Dissipation is giving me something 0.43. Okay, so it's doing something. So let's actually measure this on the peak meter and see if this can give us an ESR. I think in theory it should be able to. On. There we go. Gave us a capacitance value and an ESR 0.01 ohms. So that can read it just fine. Even though the DER struggled with it a little bit because it is, being a massive capacitor, at least for the things I do, this thing managed it just fine. So let's measure the 10 microfarad capacitor. So we've got 8.81 with 2.5 ohms. Got on the DER. and we're getting 8.87 with 8.1 ohms at 100 hertz. This is where frequency comes in. Alright, so if we go 120 hertz, it's changed it slightly. 1 kilohertz is getting much closer. Alright, so 3.5 ohms, 8.3, the capacitance value changes. So this is where frequency matters with these capacitors, because you get different values depending on what frequency you use. 2.5 ohms there, 3.8 at 100 kilohertz. So, yeah. Basically, the thing with measuring capacitors is you need to be familiar with your equipment, what your equipment would usually say. So when you're measuring capacitors and using your testers, you actually kind of need to be familiar with what they do normally. Okay, I've done some comparisons. I've got these test capacitors over here. These are my standard capacitors. These ones here can't read, they're too low value. I've got that 0.3 microfarad limit. They're both below that, they can't read them. This is the 1 microfarad standard capacitor. I've got this currently on my East Tester ET4401, which is measuring 1.0001 microfarad, 0.06 ohms at 100 hertz, and at 1 kilohertz I'm getting 1.0028 microfarads and 0.02 ohms. If I put this on my DER instead, I'll come back, and it's doing 1.006 microfarad effectively, 0.001 dissipation, we want ESR. Alright, 0.17 ESR at 1 kilohertz. Let's go down to 100 hertz. You got 0.7 ohms and 1.001. Alright, so there's a bit of variation there depending on frequency and testers. So let's look at the peak, see what that thinks of it. .06 microfarad, 1.45 ohms, so that's a significant difference in resistance. That sort of makes you wonder a little bit about the accuracy of the ESR measurement of this. I don't know if that's correct or not, but is it my other two testers are wrong and this one is right? Or is it the other way around? Is it because of the frequency? Because don't forget this is measuring between 50 and 100 kilohertz. I can do 100 kilohertz in DER. Let's have a look at that. 10 kilohertz, I'll do that one on the way there. 100 kilohertz. So, inconclusive, isn't it? Because the capacitance on this is really close. You know, it's within the spec, I think, is it plus or minus 4% plus a certain number of counts as well. So I think it was in spec, but it made for the reading of the capacitance. But the actual resistance reading is interesting, isn't it? You know, 1.45 versus less than 1. So which one's right? Don't know. Makes me suspicious. So I also have this ESR meter, which is a silicon chip one, right? This is the Bob Parker ESR meter. A lot of people swore by these things. Stick this on here. 1.6 ohms if I short the probes out. Getting 0.1. Just to null these out. Look at it again. Don't forget the peak was saying 1.45. You get 1.3 ohms on this ESR meter. This one's getting closer to the peak. Interesting. Okay, it's getting serious. 2 more ESR testers. We need to find which ones seem to agree with each other, shall we? So we got this ESR100. I showed this one quite some time ago, actually. Alright, let's zero the test leads on this thing. Hook them up. What do we get? About 0.1. Kind of agrees with the other meters. This one's at 100 kilohertz, I think. Then we got the Unity UT612. Let's try this one. This is very much like the DER, actually. This one's very similar. ESR 0.03, and we're running at 1 kilohertz. Let's change frequencies. 10 kilohertz. 100. Very different there. And 100 hertz. Again, 0.5 ohms. So we've got some which agree with the DER, and we've got some which agree with the peak. Which one's right? I don't know. Well, I should say we have one which agrees with the peak. So we've got 4 meters which are all showing less than 1 ohm, usually about 0.1 or so, 0.2 in that region. So we've got 4 meters all saying the same thing, basically. Then we've got the peak which says 1.4, and the Bob Parker silicon chip ESR tester which does 1.3. Which one's right? You be the judge. Does it matter? I don't know, they probably will spec. Okay, let's do another test. Let's test this capacitor here. 10 microfarad, 450 volt. Let's test this cap across all the meters and see what they say. So 9.65, 2.9 ohms. You got that? 9.65, 2.9 ohms. 3.3 ohms. Now this is closer. It's only 0.4 ohms out. Let's change frequencies. So maybe it's because of the standard capacitor. Maybe it's because I'm using that. I don't know. Let's go down to 100 hertz. 100 hertz. That's the frequency I tend to use for everything. All right. Yeah, 9.6, 8.6. 1 kilohertz was what it started out as. 5. If I use 10 kilohertz, it's 2.7 at 10 kilohertz. 100 kilohertz, 2.5. So in this case, I don't know. What do you want to make of that? Next one. Go back to this one again. Display on this doesn't show up too well, I'm afraid, on camera because of the lighting. 1.9 ohms. So it's reading a bit lower. Let's do a short here actually, just to make sure it looks like it shorts out alright. Zeros? Yeah, pretty much. Different again. Back to DR. 2.9, that's actually really close to the peak. Oh, so you can't see it. There you go. At 1 kilohertz, 2.9 ohms. This is really close to the peak on this particular one. So let's change frequencies. 10 kilohertz. Yeah, it's different there. 100 kilohertz. Come on, get there. Can't read at 100 kilohertz. 100 hertz. 8.5 ohms. Yeah, well, you know. 1 kilohertz is the more accurate to use for comparisons between these because that's what they should be. That's like the standard frequency, which is why I default to 1 kilohertz. Even though I tend to use 100 hertz because that's usually more applicable. Okay, and the ESR tester, which you can't see on camera right now, shows 2.8 ohms, which agrees with the peak, and 9.3 microfarad at 1 kilohertz. Let's change frequencies. Let's do 10 kilohertz, 2.3 ohms, 8.6 microfarad, 100 hertz, 8.5 ohms, and 9.7 microfarad. Again, that's also very close to the DER and stuff. Let's just refresh my memory on this one. .7 microfarad, 2.3 ohms. So yes. Did I say 2.8 before? I'm pretty sure I did. Let's do this again. Oops, it's not hooked on properly. Do a new test. Yep. This one says 2.3 ohms now. I thought it said 2.8 before. Anyway, 9.7. Maybe it's exercised the capacitor a little bit, so it's changed slightly. It's always fun, isn't it? So let's go back onto this one here. At 10 kilohertz I was getting 2.3. I shall show you. Let's do that. Right, so 100 hertz we're getting 8.4. 1 kilohertz we're getting 2.8, which is what I thought we got on this originally. 10 kilohertz we're getting 2.39, basically 2.4. And 100 kilohertz we're getting 2.26. Now don't forget this is supposed to be between 50 kilohertz and 100 kilohertz. That would kind of align. If these frequencies are halfway between, then it would be about halfway between directly, which means that agrees with us. Capacitance doesn't agree, but yeah, well, you know, that's because of the frequency probably. 100 hertz, 9.7, here you go. But it's supposed to be 1 kilohertz test, isn't it? So we get 9.3 and 2.9 on this one. It's all very subjective. You need to know your gear. That's what I'm trying to say. You need to know your gear. You need to know what you're normally going to get because you can see these discrepancies between these meters. They're all very similar, but they're different. If you're one of them. Oh, I need to get the Bob Parker one back out. And the Bob Parker one, 2.4 ohms. It's basically agreeing with that one. Still. So what I'm trying to say about this comparison between these different meters is that you have to know your gear. You know, you have to be familiar with what your gear would normally show you. These two basically are the same. These and these are the same under certain circumstances. It depends. You know, it depends on the capacitors, I think. So you have to be familiar with your gear. If you've got one of these and using this all the time, you know what is normal for it. These all pretty much agree with each other, but they're different to this one and this one. I don't know. How wrong are they? Does it really matter? Probably not, in reality. I mean, I'm looking at a really small value. You're looking at 1 ohm difference, right? In reality, in most cases, probably doesn't matter. You know, if you're looking at small value stuff, 1 ohm is very little, it's like negligible difference between these. They're all well within spec, right, for what they consider allowable values. You know, for a good capacitor, 1 microfarad, 1 ohms is like nothing, really, right? When you get into big value capacitors, then it matters, but then I think they're more accurate across each other anyway. We looked at that 15 microfarad one before and it was fine, no issues there at all. Yeah, you have to know your gear. This, I would definitely trust. They make good stuff and I've always been really happy with what they make. You can see the design and everything aside, it's complicated, there's a lot to it, alright? They're nice meters. But yeah, you have to know your stuff. Each one's going to read a little bit differently, that's just the nature of it. And yes, you may, although I didn't show calibration of these, I have calibrated these before I used them all. Didn't show you that, I did calibrate all of these before I did that. I did show the zeroing on this one, didn't I? Yeah, I didn't show it, but I have done it. So in case you say, oh, you haven't zeroed them all, or you haven't done a calibration on them, yeah, I have, I've done it. Right. This is what the video is about, is this one. Recommend you get one. It does one thing, it does well, and it's quick and simple. It's almost as simple as this thing. Right, this is super simple, but this only gives you ESR, it doesn't give you capacitance. I don't think you can even get these things anymore. You can get these MSRs, you can get these, but these don't tell you that much. And it's not a very nice display. You know, it's not easy to see. It's just, I don't like that one that much. The DER I quite like, and the Unity one is actually very similar to DER. Those two were very close when I did all the testing on these when I originally got them. It's subjective, unfortunately. Maybe someone that knows a bit more about capacitor testing than I do can comment down below. I know there's some really clever guys that watch my videos. Maybe comment down below if you've got anything else to add to that. So let's actually open this up. Let's do that now. Oh, I'll just push the button. Let's see what's inside this thing. I don't know much there is to see, I've never opened it up yet, so it's only just arrived. I need a little bit of a play with it. There you go. Wow, how's that for inside? How's that? Isn't that nice? Beautiful board. Now, when you're actually doing testing, you can actually hear this relay clicking, so you can actually hear that just a little bit, just a little gentle click. I knew it was relaying now, I could hear it. I've only got the probe right here, so if you were to damage this cable or need to replace it, you can actually do that because the shoulder joints are right there, it'd be easy to do. What's that? Is that a PIC? Yep, PIC microcontroller up here. 74HC4066. And again, and again. What's that on there? MCP 6004, is that? Pretty hard to see it. And some current sensing resistors, I'm guessing, down here as well. Quite large resistors, so they're probably used for currents or discharging. So one thing this has is discharging, so if the unit measures a voltage on a capacitor when you do the test, it would actually do a discharge first to protect itself. So I think it does up to 1 minute of discharge, then it will fail because it's too big a charge in it. Obviously, because otherwise it will end up overheating, so I'm guessing it's dumping the energy from the capacitor into these resistors here. Protection diode, obviously little boost regulator here, because don't forget it's only 1.5 volt battery. Nice, it's a really nice design. It looks beautifully made. Does it come out? It does lift out. Let's look at the other side. And there you go, that's also on the other side. 2021 design. Nice. So I was going to go and put this thing away in my drawer and I discovered that I actually have a few already, and well, I knew about these ones, but I've realised I've actually got two Zen 50s here. I don't know how I purchased two. Obviously I had one then, this is the one I got a couple of weeks ago, well a few weeks ago now I think. That's the one I've recently obtained, and this is the original one, which turns out I've completely forgotten I even had. Anyway, so I've got a collection of these now. I wanted to say as well, what I've got, I was looking at this information here about this, and I sent the video information to Jez, Peak Electronics design head guy. I think it was actually the guy who designed these things. He provided some extra information about how this thing works, which actually explains a lot what we're seeing with doing those capacitor tests. So one of the things he pointed out is that the unit basically ignores the reactance of the capacitor, so you get a slightly different ESR reading. So the 50 kHz or 100 kHz sort of range that it uses for test frequency, that's only for the ESR measurement. And that the capacitance measurement is basically done at DC, which is why we're seeing the same capacitance readings at low frequency on the other testers as we're seeing on the screen here. So that kind of explains why we're getting a match with the capacitance, because this is basically DC testing of the capacitance value, whereas the frequency is only used for doing ESR measurement. And it basically ignores reactance, which apparently a lot of the other testers don't do. So he was saying that a lot of the other testers' reactance will affect the readings because they don't actually allow for that, whereas this does allow for reactance of the capacitor, and so it gives a more accurate reading in that way. And if I actually go back to the manual here, it does actually mention this aspect of it about the reactance of the capacitors being ignored by the ESR70, so they give you a better reading. So it does actually mention this specifically in the manual. I probably did read that but then forgot about it again. In fact, what I'm going to do is I'm going to read out the statement that Jez sent me, because I think he actually explains it incredibly well, probably far better than I'm explaining it. He says, it's worth saying that the test frequency at 50 kHz used by the ESR70 Gold is for the ESR measurement only. The capacitance is effectively measured at DC, so that will generally correspond better with the capacitance measurements of the other testers at low frequencies. Also, most other ESR meters don't take reactance of capacitance into account. The ESR70 automatically eliminates the capacitor's reactance, which is very frequency dependent and is very significant for low capacitances. For example, one microfarad capacitor has a reactance of 3 ohms at 50 kHz, and that can erroneously influence ESR measurements, and some other meters we ensure that the reactance is eliminated from measurements so you are left with pure ESR values. So I think it explains it pretty well. So Jez said the capacitance measurement is being effectively DC, which means it must be a very low frequency or something, I'm not sure. But that explains why we're getting those matching readings of capacitance at low frequency in the other testers. So that explains that part of it, and that all makes complete sense. It matches what we observed. Something else Jez wanted to point out, as I did actually put in the description of the video, is that Peak is only a really small company. It's like 70 employees, and they're really proud of the fact they're all UK based, UK designed, UK manufactured, and so they really wanted to push that point in the review video as well, as that they're a UK company and it's all fully UK based. It's not made in China and all that like a lot of these other units are, so he wanted to really push that as well. So I thought I'd chuck that in the video, why not? Some people might like the fact it's made in the UK instead of in China. Unfortunately most things are made in China these days, for better or worse. I don't know. Anyway, now I've got to figure out what I'm going to do with 2 Zen 50s. Don't need 2 Zen 50s. What should I do with the other one? Which one's new? I think this is the new one. They've got different stickers on the front. But this matches these ones, so that matches that one. This is old. This is my original. I've had this one for a long time. I think I had that one about a year. This one I just got, obviously. This one I just got, I think. So I think that's the old one here, because it matches this design. And this is the new one. Let's just have a look at these. Zen 50 version 1.4. Version 1.4, so they've got the same firmware and everything on them, so it's probably just a physical sticker. It's like the same actual software is running on them. Very good meter. Like it a lot. So thanks a lot Peak for sending this to me at no cost. Much appreciated. I've got another little tool to use here. Adds to the uncertainty principle with all these 7 meters, and also something slightly different. As they do. Welcome to metrology. There's a playlist here, things I think you should watch, probably multimeter reviews. Go and check those out. There's a playlist here, YouTube things you should watch. Here's a subscribe link if you haven't already subscribed. Make sure you do that and click the bell. There's a Patreon support link over here. Don't forget to click like. Bye.